Greetings to dear friends, thank you for choosing the BigDark channel for teaching scientific content. Please do not forget to subscribe, like, and comment to support the channel. Ozone layer. The ozone layer or ozone shield is a region of Earth's stratosphere that absorbs most of the sun's ultraviolet radiation. It contains a high concentration of ozone, O3, in relation to other parts of the atmosphere, although still small in relation to other gases in the stratosphere. The ozone layer contains less than 10 parts per million of ozone, while the average ozone concentration in Earth's atmosphere as a whole is about 0.3 parts per million. The ozone layer is mainly found in the lower portion of the stratosphere, from approximately 15 to 35 kilometers, 9 to 22 miles, above Earth, although its thickness varies seasonally and geographically. The ozone layer was discovered in 1913 by the French physicists Charles Fabry and Henri Buisson. Measurements of the sun showed that the radiation sent out from its surface and reaching the ground on Earth is usually consistent with the spectrum of a black body with a temperature in the range of 5,500 to 6,000 K, 5,230 to 5,730 degrees Celsius, except that there was no radiation below a wavelength of about 310 nanometers at the ultraviolet end of the spectrum. It was deduced that the missing radiation was being absorbed by something in the atmosphere. Eventually, the spectrum of the missing radiation was matched to only one known chemical, ozone. Its properties were explored in detail by the British meteorologist G.M.B. Dobson, who developed a simple spectrophotometer, the Dobsonmeter, that could be used to measure stratospheric ozone from the ground. Between 1928 and 1958, Dobson established a worldwide network of ozone monitoring stations, which continue to operate to this day. The Dobson unit, a convenient measure of the amount of ozone overhead, is named in his honor. The ozone layer absorbs 97 to 99% of the sun's medium-frequency ultraviolet light, from about 200 nanometers to 315 nanometers wavelength, which otherwise would potentially damage exposed life forms near the surface. In 1976, atmospheric research revealed that the ozone layer was being depleted by chemicals released by industry, mainly chlorofluorocarbons, CFCs. Concerns that increased UV radiation due to ozone depletion threatened life on Earth, including increased skin cancer in humans and other ecological problems, led to bans on the chemicals, and the latest evidence is that ozone depletion has slowed or stopped. The United Nations General Assembly has designated September 16 as the International Day for the Preservation of the Ozone Layer. Venus also has a thin ozone layer at an altitude of 100 kilometers above the planet's surface. Sources: the photochemical mechanisms that give rise to the ozone layer were discovered by the British physicist Sidney Chapman in 1930. Ozone in the Earth's stratosphere is created by ultraviolet light striking ordinary oxygen molecules containing two oxygen atoms, O2, splitting them into individual oxygen atoms, atomic oxygen. The atomic oxygen then combines with unbroken O2 to create ozone, O3. The ozone molecule is unstable, although, in the stratosphere, long-lived, and when ultraviolet light hits ozone it splits into a molecule of O2 and an individual atom of oxygen, a continuing process called the ozone-oxygen cycle. About 90% of the ozone in the atmosphere is contained in the stratosphere. Ozone concentrations are greatest between about 20 and 40 kilometers, 66,000 and 131,000 feet, where they range from about 2 to 8 parts per million. If all of the ozone were compressed to the pressure of the air at sea level, it would be only 3 millimeters, 1/8 inch, thick. Ultraviolet light. Although the concentration of the ozone in the ozone layer is very small, it is vitally important to life because it absorbs biologically harmful ultraviolet, UV, radiation coming from the sunday. Extremely short or vacuum UV, 10 to 100 nanometers, is screened out by nitrogen. UV radiation capable of penetrating nitrogen is divided into three categories, based on its wavelength. These are referred to as UVA, 400 to 315 nanometers, UVB, 315 to 280 nanometers, and UVC, 280 to 100 nanometers. Ozone is transparent to most UVA, so most of this longer wavelength UV radiation reaches the surface, and it constitutes most of the UV reaching the Earth. This type of UV radiation is significantly less harmful to DNA, although it may still potentially cause physical damage, premature aging of the skin, indirect genetic damage, and skin cancer. Distribution in the stratosphere. The thickness of the ozone layer varies worldwide and is generally thinner near the equator and thicker near the poles. Thickness refers to how much ozone is in a column over a given area and varies from season to season. The reasons for these variations are due to atmospheric circulation patterns and solar intensity. The majority of ozone is produced over the tropics and is transported towards the poles by stratospheric wind patterns. In the northern hemisphere, these patterns, known as the Brewer-Dobson circulation, make the ozone layer thickest in the spring and thinnest in the fall. Research has found that the ozone levels in the United States are highest in the spring months of April and May and lowest in October. While the total amount of ozone increases moving from the tropics to higher latitudes, the concentrations are greater in high northern latitudes than in high southern latitudes, with spring ozone columns in high northern latitudes occasionally exceeding 600 Du and averaging 450 Du, whereas 400 Du constituted a usual maximum in the Antarctic before anthropogenic ozone depletion. Depletion. The breakdown of ozone in the stratosphere results in reduced absorption of ultraviolet radiation. Consequently, unabsorbed and dangerous ultraviolet radiation is able to reach the Earth's surface at a higher intensity. Ozone levels have dropped by a worldwide average of about 4% since the late 1970s. For approximately 5% of the Earth's surface, around the North and South poles, much larger seasonal declines have been seen, and are described as ozone holes. The discovery of the annual depletion of ozone above the Antarctic was first announced by Joe Farman, Brian Gardner, and Jonathan Shanklin, in a paper that appeared in Nature on May 16, 1985. Regulation. To support successful regulation attempts, the ozone case was communicated to laypersons with easy-to-understand bridging metaphors derived from the popular culture and related to immediate risks with everyday relevance. The specific metaphors used in the discussion, ozone shield, ozone hole, proved quite useful and, compared to global climate change, the ozone case was much more seen as a hot issue and imminent risk. Lay people were cautious about the depletion of the ozone layer and the risks of skin cancer. In 1978, the United States, Canada, and Norway enacted bans on CFC-containing aerosol sprays that damage the ozone layer. The European Community rejected an analogous proposal to do the same. In the US, chlorofluorocarbons continued to be used in other applications, such as refrigeration and industrial cleaning, until after the discovery of the Antarctic ozone hole in 1985. After negotiation of an international treaty, the Montreal Protocol, CFC production was capped at 1986 levels with commitments to long-term reductions. This allowed for a 10-year phase-in for developing countries, identified in Article 5 of the Protocol. Since that time, the treaty was amended to ban CFC production after 1995 in the developed countries, and later in developing countries. Implications for astronomy. As ozone in the atmosphere prevents most energetic ultraviolet radiation from reaching the surface of the Earth, astronomical data in these wavelengths have to be gathered from satellites orbiting above the atmosphere and ozone layer. Most of the light from young hot stars is in the ultraviolet, and so the study of these wavelengths is important for studying the origins of galaxies. The Galaxy Evolution Explorer, GALEX, is an orbiting ultraviolet space telescope launched on April 28, 2003, which operated. Thank you for being with us until the end of the program. Be sure to mention your opinions about the educational video in the comments section.